So this is part one of the information for the day that I'm absent, which is June the 5th. This is the going over homework for chapter one information. All right, let me talk about the information here. We've got the first set was going back and forth between milliliters and liters. So the first one starts out in milliliters and you are converting to liters. Remember that this is a 3 decimal place move. So your decimal, which was behind the 5, moves left 3 spaces, which is a 1,000-fold move, to give you 1.375 liters. If you are going in the opposite direction, if you have 0.067 liters and you are converting back to milliliters, you are multiplying by 1,000, and this moves your decimal place 3 spaces to the right. Then we have some sig figs, some of which have decimal places and some which don't. 4,260. So there is no decimal place shown. We are to presume then that the 0 at the end of the number is not significant. So only 3 sig figs. 900. Again, no decimal point present. Only the 9 is significant. So 1 sig fig. Then we have leading zeros. The one in front of the decimal place, as well as the other 2, are all leading and not significant. Only the 3 and the 7 to make 2 significant figures. And then the last one has a visible decimal place, despite the fact that there are some zeros at the end. You are expected to count those as significant because whatever value this is being reported to the 10th place. So there are 4 sig figs. Then we have sig figs in calculations. And I did make an effort not to mix and match the 2 rules. There is the adding subtracting rule, which is least number of decimal places in your final answer. And there is the multiplying dividing rule, which is least number of sig figs regardless of decimal points. So 956.3, add to it 8,748.004. So the first answer is your calculator value, but it is not correct in terms of reported sig figs. You have the 0.304 there on the end. I only want 1 decimal place in my final answer because there was only 1 in the 956.3. So 9704.3. Then we hit to multiplying and dividing. So 64 times 6.39 times 10 to the 4th. So you need an exponent. Your calculator will give you multiple digits that are all reported by the calculator. So 2361600. But you're only allowed to report 2 sig figs. I wrote it in scientific notation, so 2.4 times 10 to the 6th. You could write it as 2,400,000 and put zeros after that, which also then only reports 2 significant figures. Dividing, 787.667 divided by 48. You get quite a number of decimal places on your calculator. 16.409729. But note, the 48 in my division is only 2 sig figs. my answer must be rounded all the way down to 2 sig figs. The last one, 365.2 minus 41.033. Your calculator has 3 numbers after the decimal point. We've got 324.167, but I need to round it to a single decimal place of 324.2. Then there are some one-step conversions. So you could either use your appendix from Appendix A from your lab book, or you could Google the conversion rate. That actually doesn't really make a big difference. But they are both single-step conversions. I did not ask you to report with correct number of sig figs, so the purpose of this is to make sure you are doing the mathematical part correctly. So 75 times 1.094 over 1 meter gives you 82.05 yards. And 11 ounces times 1 over 0.03527 will give you 311.88 grams. All right, then multi-step conversion. So I gave you 27 million acre feet. It's often how they measure large bodies of water in terms of their capacity. So I also gave you one of the weirder conversion factors here. So an acre foot is 43,560 cubic feet. You can look up in your lab book how many liters are in a cubic foot as your second conversion factor. I did this in 2 steps. I did the 27 million times 43560. It gives me a very large number, 1.176 times 10 to the 12th. And then I multiplied by liters per cubic foot. Again, increases your value. So 3.33 times 10 to the 13th liters. But it does say that with current drought conditions, the lake is only 31% full. So you are multiplying by 0.31, or you could multiply it by 31 over 100, same difference mathematically. And that will give you 1.03 times 10 to the 13th. For conversions between temperatures, from Fahrenheit to Kelvin, so 2 steps to this conversion, I'm going to do the 5/9 times my 550 minus 32. Make sure you are doing what is inside parentheses first. That will give you 518. 5/9 times 518 will give you 287.8. And then add your 273, and this should give you 560.18. Remember that I am traditionally reporting my temperature values to a single decimal place, partly because that matches the equipment in our lab. -17 Celsius. Okay, so this one, multiply your -17 times the 9/5. You have a -30.6. Add your 32, and this will give you 1.4 Fahrenheit. So the next one has a mix of conversion factors with the density. Remember, I said treat this as if you have a square but thick steel deck plate. So 12 inches times 12 inches times 1/4 of an inch. I went ahead and converted my inches over to centimeters before I multiplied them together. It seemed the most straightforward. It doesn't have to be done this way. So 12 inches times 2.54 will give me 30.48. 1/4 times 2.54 will give me 0.62 centimeters. So length times width times thickness will give me 589.934. You were told that this weighs 10.2 pounds. Convert it over to kilograms, so divide by 2.2. That will give you 4.64 kilograms. I need grams, so multiply by 1,000. That will give you 4,640. And the final step is total grams divided by total volume. So 4,640 divided by 589.934 should give you 7.86. And this is in grams per cubic centimeter. Remember that the rule of thumb is if you see a density above 30, 4 grams per cubic centimeter or grams per milliliter, since they're the same thing, be deeply suspicious. It is highly unlikely to have a value greater than 30. Then we have a different density problem. Roll of toilet paper. Yeah, I wrote this in the middle of the pandemic. 227 grams. Okay, toilet paper is not very dense. So 0.144 grams per cubic centimeter. I put in my D and I put in my mass. I don't know what my volume is. I can do the little algebraic flip-flop and have 227 divided by 0.144. And that will give me 1,576.4 cubic centimeters. Nice big chunky roll of toilet paper. Scientific notation, make sure you are comfortable going in both directions. 34,000 becomes 3.4 times 10 to the positive fourth exponent. And the small number, 0.0091, becomes 9.1 to the negative third. Couple of concept stuff here at the end. So saying that cobalt compounds are pink, that is qualitative. There is no numerical value involved. It is just a visual observation. A graduated cylinder with 46 milliliters of ethanol. That one needs to be quantitative because there is a number value involved. And then last bit, if you were walking down the street on the way to class. So usually there's a mix of cars and the occasional pickup truck and sometimes the occasional motorcycle. Definitely heterogeneous. They're not all the same thing. Homogeneous, okay. Presuming that you haven't let it sit around and go flat kind of thing. It has a color, it has a sweetener, it's a liquid, it's all dissolved together. It should be relatively the same all the way through. And the last one, note solution is the key word. Anything that is designated a solution should be homogeneous. I will record the next segment for loading as a separate video, in part because I am attempting to manage the megs that I have to upload.